Right, welcome to today's stream. We're going to be looking at modelling quadratics. This is mainly aimed at IB standard level applications course, otherwise known as SLAPS, for those of you who are acquainted. Anyway, we're going to be looking at these questions. I'm going to give you 5 minutes to have a go at your first one and see how you get along with that, and then we'll go through it. So we'll stop here after 5 minutes. Okay, if you are using your calculator, as you should have hopefully finished by now, but I'll give you the extra minute just to finish off. One minute to go. Right, here we go. So the first part of the question is how high above the water is the pier? Now the question here tells us the height after time t. Okay, height of the water after t seconds. So when t equals naught, that will tell us how high above the water the pier is, because that gives you his height above the water. So if we make t equal to naught, then ht will equal 4 times naught plus 4 times naught, because naught squared is naught. So all that's naught, so plus 3, so it will equal 3. So the height will be 3 meters. Part B. How long does it take for Andrew to reach the maximum height of his dive? Now, what I suggest you do, your calculator, as you've got your calculators, is you use that to help you do this question. So what we're going to do, we're going to type in this equation. So we're going to type in minus 4t. We're going to use x because the graphical calculator uses x where we've got t's. And just go in the right place. Plus 4 x plus 3, and we're just going to draw that, and we can see if we go up we can see where the maximum is, and you can use the graph solver to find that maximum point and press maximum, and it tells you it's when x equals 5. So how long does it take? Well, x remember is instead of my t, so t is equal to 0.5 seconds to reach his maximum height of his dive. So part C. How far is Andrew above the water at his highest point? Well, quite easy. We can just read up for the y value here. It's 4. So therefore, he is 4 meters above the water. Okay. And then part D. How long does it take for Andrew to hit the water? Now he hits the water when he gets to 0. So we could again use the graph solver, and we can look for where the root is, because that gives you where it crosses the x-axis. Is one way. So it could be minus 0.5. Well, t can't be minus 0.5. So we can go to the next value, press the arrow, and it gets you the x equals 1.5. So therefore it takes 1.5 seconds. Okay, another way to do this actually, while we're here, let's just go back to the menu, is to use the equation solver. So we can go alpha A and get into the polynomial solver, and we're doing degree 2. We do degree 2 because the squared is our biggest power, and we can type in minus 4 for our first coefficient. We can type in 4 for our second coefficient, and we can type in 3 for our next coefficient and press solve. And you can see you've got 3 over 2 and 0 minus 0.5 again. So that's another way that you can do this. Bearing in mind the course, the IB SLAPS course is dependent on using your calculator. They expect you to use your calculator. So notice very little working here. We just use the calculator all the way through on this question. So let's have a look at this question. Now I'm not going to give you quite so long to do this because that was our warm-up question. I'm just going to give you 3 minutes to have a go at this question. Okay, so that's our 3 minutes up. So again, we're going to try and do as much of this as possible using our calculator. Anyway, if Jasmine makes X necklaces a day in her market store, her daily profit is given by Px is equal to minus x squared plus 20x. How much profit does Jasmine make if she makes 7 necklaces a day? So we're going to put 7 into this formula. So therefore the profit is going to equal minus 7 squared plus 20 times 7. You could just type that to calculator. I'm just going to do that without a calculator and get $91. Part B. How many necklaces should Jaspin make per day to maximize a profit? So let's put this into our profit into our graphical calculator. Put minus x squared plus 20x. Let's execute and let's draw it. And its scale has disappeared off. So I'm going to try noticing we're at $91. Let's just change our view window. Let's change our x. Well, not worried about negatives, so let's just put our lowest value there. We got to 7 necklaces a day, gives 91. So let's just make this maybe 20. Let's see what happens with 20. Scale that and see what happens when we draw that. And we can see it's still gone too high. So let's just change our y values. So let's make this about, I don't know, 150. Okay. And draw that. And we can now see our graph. So we've got a maximum value here. So let's use a graph solver to find out where that maximum value is. And we can see it's where x equals 10. So therefore, how many necklaces should she make? So she should make 10 necklaces a day. To maximize her profit. Part C, find the maximum daily profit. Well, that's what you get out when you put your 10 in. So put 10 in, we get out y equals 100. So P of x, or P of 10 we should say, because we're putting 10 into this. If you put 10 into this, you can work it out. Okay, if we do that, you could get 10 squared is 100. 20 times 10 is 200. Take 100 away from 200 gives us the 100. That's how you can calculate it. But we can just work it out from our graph. So that is how to use your graph to make it a very quick and easy question to do. Okay, let's just move down to this question. And then we'll have a look at something a little bit more interesting. Okay, so this is not a long question. I'm just going to give you, see if you can do this in a minute with your calculator. So I was just saying, giving you an extra 60 seconds to finish off because it's quite a big ask for 1 minute because of the show that. Okay, so let's have a look at this. There's a bit of algebra involved in here. If we make this length here L, then we know that we've got 200 must equal L plus x plus x. So it's 2L plus 2x. So therefore, we can find out what L is, because notice the area is just in terms of x. We can find out what L is. So L must equal 200 minus 2x. Take 2x from this side and this side. Divide throughout by 2 to get just L. So we've got 100. 200 divided by 2 is 100. Divide this by 2, we get minus x. And therefore, our area is going to be equal to x times 100 minus x. Okay. And we get 100x minus x squared. Done. Part B. Now, we can, again, put this into our graphical calculator, although it's a bit of a show that. So there's many ways to show this. And you could use it, do it with a thing called differentiation, which you'll come on to in the SLAPS course. But I'm going to just do, at this stage of the course where we're doing this testing and what have you, we're just going to be using, we're just going to be using our graphical calculator. So we're going to type in 100x minus x squared and get a picture on our calculator. And you can see it's got, again, it's gone quite big. So let's just have a look. Areas maximum when it's a square, and we've got 200 meters of fencing. So if it's a square, that must be 50 meters each. So let's go to view window and just change our x max to a bit more than that. Let's make it up to 100. It can't be more than 100, because then if the length is 100, then the width will be 0. Draw that, and you can see it still goes off. So let's make the y value different. Exit, draw, go to view window, go to our y value. Let's make our y maximum, let's make it 1000. See what happens. I could work out exactly what I need, and I can see it's a lot more. Okay, but what I can see is between, oops, didn't mean to do that, just let me get that back. What I can see is that I've got a shape of a graph which looks like this. Okay, and that was 100, and this is 50. Okay, and that gives us our maximum value. And if we go to graph solve and press maximum, then we got maximum x equals 50 and y x equals 50 and a equals 2500 is our maximum. When you come onto the calculus, for those of you who do that, so say you're a GCSE student, what happened to watch this video, then what we would do is we differentiate dA by dx, okay, and we'd get 100 minus 2x, and we get maximum value when this equals 0. So 0 is equal to 100 minus 2x, so therefore x equals 50. And we can say that it's a maximum because we've got an n-shaped graph, because we've got a minus x squared. So anything along those arguments would be good enough for GCSE and SLAPS level to say why that's a maximum. Okay. Right, let's just move on to some actual modelling problems, which are a bit further down. Let's see if I just find them. Here we go. Right, given the time, I'm just going to leave this one, which is an easier one for you to have a look at. And I'm going to go through this one. Question 9 here. So I'm going to give you, because you can use your calculator to do all this, I'm just going to give you 3 minutes to think about it and have a go with your calculator and see if you can get the answer out. To be giving you a hint, when it means by quadratic, you need to be able to find A, B, and C in this quadratic. Okay. Okay, so we're using this to try, this is the model we're going to try and create using the information given to us in the question. So we know at these 3 points, we know an x and y value, so we put them into here. So let's put the 10, 9 one in first. So the y value is 9, x is 10, so 10 squared is 100, a, plus 10b, plus c. Let's put the 20 and the 15.25 one in next. So we've got 15.25 equals 20 squares 400. You can use your calculator to work that out if you don't know it. Plus 20, x is 20, 20b plus c. Then at the 30 and the 19 point, you know the y value is 19, x is 30, square it's 900, a, 30b plus c. So we've got 1, 2, 3 equations, and we could solve those algebraically, or we can just go straight to our simultaneous equation solver with 3 unknowns. So basically what we're going to do is they talk about it as being x, y, z, okay, where we got a, b and c here, but it's going to be x, y, z on theirs, and we have to put in the coefficients of x, y, z or our a, b and c, just put them in order. So we go 100, and as long as you put them all in the same order, then you can't go wrong. And 1, and then the thing that all of this is equal to is 9. So remember, you must have all the variables on one side and the number on the other side. Okay, the number on the other side, the variables on the other side. So next we're going to put the 400 in. A bit too much. There we go. 20 and 1. And that was equal to 15.25. 15.25. Next we're going to put the 900 in. Then the 30. Then the 1. And then the 19. And we can press solve. And it says basically that a is going to be equal to minus 0.0125, which is equal to minus 1 over 80 as a fraction. The b will equal 1, and the c will equal 0.25, which is a quarter. So our equation is going to be minus 1 over 80 x squared plus the b, which is x, 1 lot of x, plus c, which is a quarter, and that is equal to y. And now we can find the maximum height reached by the ball by putting it into our graph. Oops, move it to the graph button. Eventually I'll get there. Here we go. Put it into the graph one. And we're going to type this in. So what was that value? It was minus, let's put the decimal in, it's easier. There we go. X, let's just go and delete all, oops, done that again. Let's just go and delete all the rest. X squared plus x, and we got plus a quarter, 0.25. Press execute, press draw. Let's just view window. Let's just initialize it back to the beginning, back to the basic one they always start off with. Press execute. Now draw it and see what we get. And it looks like a straight line for now. But we want to just find the maximum. We don't need to see what it looks like actually. You just trust the calculator's right. Press graph solve. Press maximum, and it's not found it. Go. Let's see where we've gone wrong. Have I typed something incorrectly? I can't see what it's done wrong. Now, if I was to do this using calculus, then what I could do is I'm going to get minus 1 over 40 times x plus 1 equals 0. So therefore x will equal to 40 is where it's going to happen. So we've got graph function y equals. Let's just try view window. Oh no, exit. Delete that. Sorry, I need a shift then a view window. Okay, it's being awkward. It's not letting me go to the view window. So let's just draw the graph. Press draw. Press view window. Let's just change our x min to 0. Okay, and our x max is going to be more than 40. So let's just put 50 in. Now put grass solve max. It's worked it out now. I think actually it probably would have worked it out anyway. Actually, let's go to view window and just change that to the initial. I think it. I might not have pressed enter. Let's just do grass solve max. Okay, so it can't do it unless you get a big enough range. I didn't know that on my calculator. I assumed it could do it. So if you do that, what we can do is we can go to draw, we get our view window, and we just make our x really big. So what we could do, watch this, you can just put in 1,000. If you're not sure, just whack in 1,000. Press draw, and then press grass solve, then press max, and it can solve it. So it comes out of x is 40. And it gives you the maximum value is 20.25. Now 1 meter boundary fence is 75 meters away with a clear, will the ball clear the boundary fence? So there's two ways we can look at that. And one way is to draw another equation in, okay, where y equals 1 and find out where it crosses. So let's draw in y equals 1. So let's draw y equals 1. Press draw, and then we can use the graph solve and find the intersection. So the first one is when x is really small, and then the next one is when x is 79. So yes, it does clear it. Okay, will the ball clear the fence? Yes, it does clear, as at 1 meter at 79 meters away. Okay, so we can do it that way. Right, that's where I'm going to stop for today. There we go. You've got a modeling question where you actually have to find out the values of the models. We went through how to use a few models. There are a few more examples you can go on here. And if you got the textbook that I use, then you can link to the answers and use that link to find the answers. There we go.